Welcome back, ladies and gentlemen. In this video, we'll be talking about significant figures, or sig figs as they are commonly referred to. So how we state numbers in physics matters. We have to assume that when we are dealing with questions, we have to assume that all numbers in questions have been measured. Okay, and in any measurement, there's going to be some uncertainty. Okay, so significant figures just refers to the meaningful digits that we should be recording in our answers. Okay, so the sig figs are always going to include the numbers that are certain, and then plus one uncertain measurement, which is estimated between the smallest scale divisions. So for example, if you look at this ruler, we have a line that comes out to here. Okay, and we can safely say that that is 16.12 something, and then we're estimating that increment in between the 16.2 and 16.3. So this 8-digit would be an estimate. Okay, so there's a little bit of uncertainty there. Okay, so how we measure values is really going to matter. Okay, and this is often determined, or always determined, by the type of tool that we are using to measure things. Okay, so we'll just run through some rules here. There is a big long number. So first of all, when we talk about non-zero digits, these are significant. So I'm just going to put sig with a little check mark. So a number like 2.3. Okay, so we're talking about decimal places. We're talking about the number of places past our decimal point. So this would have one decimal place and 2 sig figs. Okay, trailing zeros after a decimal, or trailing zeros in general, we also call those significant. So if we increase this number, say we're using a more precise measuring tool, to 16.380. Okay, so the 2, the 3, and the 8, those are all significant because they are non-zero. And then this 0 at the end is a trailing zero, so it's also significant. So we would have 4 sig figs here. Okay, and then the number of decimal places, that becomes important when we add and subtract below. This is going to be 3 decimal places. Okay, so what about a number like 0.0431? Well, that is going to have 4 decimal places. Okay, but our leading zeros in a number, these are not significant. Not significant. Okay, and that's because, we could go and, let's say we're using a measuring tool like a meter stick, and we measure something to be, in this case, 0.0431 meters. Well, we can also write that number as 4.31 centimeters. So the zeros up front are really just kind of placeholders. It just depends how we want to write that number. So the number of sig figs in this example, 0.0431, would be 3. Okay, there are some other special examples, like if we were to do a count of people. Any kind of count that has, we call that just an infinite number of decimal places and an infinite number of sig figs, because we can say with certainty, if we're counting people, that there are 16.000000 forever decimal places, and therefore also sig figs. Okay, so how about a number like 708.10? Okay, so now we have an in-between digit. Now we have an in-between zero, and that number, that definitely matters, so that is also going to be significant. Okay, so in this question, 708.10, we have 2 decimal places, and then all of the other digits in here, 7, 0 is an in-between, 8, the 1, and this trailing 0, they are all significant. So we would state that is 5 sig figs. Okay, then one last one. If we have a number like 1500, there are 0 decimal places and then 4 sig figs. Okay, now for those of you that are taking Chem 11, they will tell you that it's in this example where you have trailing zeros before a decimal place. This example, they would probably say that there are only 2 sig figs. And in physics, we are going to respectfully disagree with our chemistry counterparts. So we'll just make a note here that this is different than in chemistry. Okay. Okay, so now if we start to think about doing some math with sig figs, when we add and subtract, with sig figs, you're going to round your answer to the fewest number of decimal places. Fewest number of decimal places. Okay, so if we look at our example here, if we were just going to add this up, punch these numbers into our calculator, we get 23.27. And then we have to kind of look back here and realize, hey, this has 2 decimal places. This one has 1 decimal place. This example or number has 2 decimal places. So we would have to chop this answer to, we'd have to chop this answer to the fewest number of decimal places, which is 1. Okay, so we'd put I like to call this the chop line, and then 7 becomes our rounding digit. So this number we would state as 23.3. Okay. Okay, so next, if we're talking about multiplying and dividing using sig figs, with multiplying and dividing, it's a little bit different. We're going to round our answer to the fewest number of sig figs, to the fewest number of sig figs. Okay, so a couple of examples here. If we just plug and chug 8.35 times 4.2, we get 35.07. Now I'm just going to go back and analyze, hey, how many sig figs are in 8.35? Well, there are 3. And in 4.2, there are 2. Which of these is the fewest? It's 2. So we're going to need to round our number to 2 sig figs. So I'm going to put a little chop line in there, I like to call it. Excuse me. Little chop line. So 0 is our rounding digit. So we would state this answer as 35. Okay, or 2 sig figs. Okay, our last example here, 218.4, that has 4 sig figs. 0.0143, that has 3 sig figs because our leading zeros are not significant. If we plug and chug this, we're going to get 15.272.72. Okay, and we want to round that to 3 sig figs. So to do that, we would just state this answer into scientific notation. We kind of want to chop this here. Okay, so we want to state 3 sig figs, so we'll use scientific notation in this example, where it would be 1.53 times 10 to the, well, how many times do I have to move my decimal place from where we start and where we end? That will be 1, 2, 3, 4 times. Okay, so in general, when stating answers in Physics 11, we're going to round our answers to the fewest number of sig figs. Fewest number of sig figs. Okay, so as we get into questions where numbers are coming across us, again, we have to assume that they're measured, and this will be a final check for us at the end of our answer to state our answer with the fewest sig figs. Okay, so that'll get you started with sig figs, some practice in your worksheet practice, and thanks very much, and we'll see you again soon.